Alright guys, welcome to episode 2, and today we're going to give our character the ability to move around. But first, I'm going to create a new folder and call it scripts. Let's just get some organization happening right here. Going to drag my input manager into it, but not my player controls script because it's linked to this player controls asset, so let's just leave that out here with that. I'm also going to create another folder, and I'm going to call this one art. And I'm just going to drag in my model and my game object. Just want to keep the assets nice and neat and tidy. Try to stay on top of that early in the game. It's very important. Will make your life a lot better in the long run. So I'm going to create a new script in the scripts folder, and I'm going to call this player locomotion. And we're going to handle the functionality to move our player on this script. So let's open it up. All right, I'm going to get rid of the start and update method for now. So we're going to go through this nice and slow. And the first thing I'm going to do on this player locomotion script is I'm going to create a public void handle movement. And this will be the function that handles moving our player around. So first we're going to need a couple of things right off of the get-go here. I'm going to start by making a vector 3. We're going to call that move direction. And this is going to dictate, obviously, the direction in which our player is going to move at any given time. I'm going to say move direction is equal to camera. I'm going to call this camera object. We haven't made that yet. Don't worry, we're going to in a second. Dot forward. So as you know, in the last video, we made our input manager, and we gave our input manager the ability to give us a value based on what direction we're moving the joystick, or if we're pressing the W, A, S, or D keys. And that value is separated into two separate values. We have a movement on the x-axis and y-axis. So depending on if you're moving the stick up, down, left, or right, or if you're moving the stick of a combination of both ways, like up and to the right, or hitting a W and D key at the same time, it will give you some values. And what we're going to want to do is we're going to want to use our move direction, and we're going to utilize both of those values. But first, we're going to utilize the vertical value. So we're going to want to say, hey, let's move our character in the direction the camera is facing, multiplied by how much we're moving the joystick up or down. Let's say our movement input. Our direction will be the direction of the camera is facing forward, and the amount will be our movement input. So let's make a transform and call that camera object. And basically this means our movement direction will be whatever way the camera is facing, multiplied by how much movement we're pressing from the movement input. So let's call our input manager up here, and then let's make an awake method. And let's say input manager equals get component input manager. And the awake method, all it does is it's called before start. I like calling it to initialize variables. And we're calling the input manager on get component because we're going to place it on the same game object as we're placing the player locomotion. So over here in the input manager, as you can see, we have a movement input, vector 2, which takes in the x and y variables of our movement. Well, let's make a public float just for our vertical input and a public float for our horizontal input. And what we can do is we can actually split this vector 2 into two separate independent variables, which is what we're going to do, which is why we wrote out here our vertical and our horizontal. So this vector movement input just takes in our WASD keys or our joystick and gives us a value on the x and y axis based on what we're pressing or what direction we're pulling the joystick. So let's make a private void handle movement input. And let's say vertical input is equal to movement input dot y. And what it's doing is it's taking the vertical input variable up here and it's giving it the value of the y-axis on the movement input, so the stick direction going up and down. And likewise, we're going to say horizontal input is equal to movement input dot x. So that will take the one value from the movement input variable, the left and right, and that will give it to this horizontal input. So for example, if it's left, it'll be -1, and if it's right, it'll be +1. And if it's nothing, it will be 0. The same thing we said for the vertical input, except for up and down. So back on the player locomotion, what we can say is movement direction equals camera object dot forward times input manager dot vertical input. So we're going to move in the direction the camera is facing, multiplied by our vertical input. We can also say then move direction equals move direction plus our camera object dot right times input manager dot horizontal input. And what that's going to do is allow us to move left and right as well based on our horizontal input and based on the camera's direction. And then we're going to say move direction dot normalize. And all normalize does is it takes a vector, particularly in this instance, our direction, and it keeps its direction the same, but it changes its length to 1, keeping it nice and consistent. So next we want to say move direction dot y is equal to 0, because we don't want our player to be walking straight up in the air and going straight up out into the sky. That would be not a desirable effect. Now, all we have to do is say vector 3, I'm going to say movement velocity is equal to movement direction. Now you don't need to declare this as a variable, but I like doing it so it's nice and clear what we're saying here. And then we're going to use something called a rigid body, which is how we're going to move our character. So we need to declare our rigid body first, and we actually don't have one set up on our player, but we're going to do that after we're finished with the scripts. All we're going to say up here is rigid body, and you can give it a name of any sort. I am going to call mine player rigid body, nice and very descriptive. And down here, you can say player rigid body dot velocity equals our movement velocity. So it's going to move our player based on the calculations we just made. That's all it does. Very simple, very straightforward, very nice, very clean. And we're going to call that rigid body on awake right below our input manager. But first, let's make a public float movement speed, because we can actually edit the speed at which we move based on this float. I'm just going to initialize it at 7. 7 seems like a pretty fair speed for my past experimentation. What we can do then is we can say move direction is equal to move direction times movement speed. And make sure you're placing this right below move direction.y equals 0 and right above vector 3 movement velocity equals move direction. And then what you will have is you're able to edit the speed on the fly from the script by editing the movement speed variable. Next down here under input manager, I'm going to say player rigid body equals get component rigid body, because we are placing the rigid body on the same game object as the player locomotion script and the input manager script. Okay, cool, let's save that. Now we have a way for our player to move, but we also need to rotate, because right now we can only move in directions, but we also want our game object itself to rotate, otherwise it will look a little silly. So let's make a public void handle rotation. Now in a somewhat similar fashion, we're going to say vector 3 target direction, almost like our movement direction, but we're going to say equals vector 3.0. So that's just basically saying it's 0 on all values starting out. Now this target direction is the direction we want our player to rotate when we move. Then we're going to say target direction is equal to camera object dot forward times input manager dot vertical input. So it's just like above so far. Target direction equals target direction plus camera object dot right times input manager dot horizontal input. So far it is the exact same thing as above. And then we're going to again normalize it. We're searching for the direction now that we want to rotate based on what buttons we're pushing. So if we're moving forward, we want to rotate our player forward. If we're moving backwards, we want to turn the player around. So you're always facing the direction in which you're about to run. So if I'm going to run to the left, I'm going to turn first to the left and then run to the left, if that makes a clear visual in your head. So then we're going to say quaternion, this word differs, target rotation, and quaternions are used to calculate rotations in Unity. So we're going to say target rotation is equal to quaternion dot look rotation. So it means we're going to look towards our target direction. So all this means, put simply, is that we're looking towards our target direction, and where we're looking is where we want to rotate. That's it. Then we're going to say quaternion player rotation equals quaternion dot slurp, which is basically a rotation between point A and point B, and we're going to use our current rotation, so we can say transform dot rotation, and our new rotation, which we got from pressing the movement keys, which is our target rotation. Okay, and then we can do that by a speed. So let's actually go up top, and as we did with our movement speed, let's make a public float rotation speed. And I'm going to initialize mine at, say, 15. Again, through experimentation, seems to be a pretty fair speed. You can adjust yours however you like. Coming back down here again, I'm going to say rotation speed. I'm going to times that by a thing called time.delta time. And time.delta time should be used when you want movement or any other constant variable change to be the same speed no matter the frame rate, because the frame rate will always differ. If you want a further explanation on that, I can make a video on that in the future. Don't worry too much about it right now. Now, I'm going to say transform.rotation equals player rotation, and we are finished right there. And now we have a function to move our player and to rotate our player. So let's move swiftly along and hook all of this stuff up, because we have the functions, but we're not calling them anywhere or activating them. So we need to do a couple more things first. Let's go over to our input manager, and as you can see, we have this handle movement input function, but we're not calling it anywhere. It's not being used. So let's right click here in the scripts and let's create a new script. I'm going to call this one player manager, and this is going to handle calling everything and running it. Think of this script as a script used to run all functionalities we create for our player. So I'm going to make the awake method, which again is called before start and is used to initialize things typically. I'm going to declare a variable of type input manager. So we're calling upon our input manager script. I'm going to call it input manager, and I'm going to declare a variable of type player locomotion. So our player locomotion script, and I'm going to call it player locomotion. And I'm going to say in the awake method, input manager equals get component input manager, because again, when I do put the scripts on the player, these will all be resting on the same game object. And then I'm going to say player locomotion equals get component player locomotion, because it's going to scan the game object that this script is on for a script of type player locomotion. Next, I'm going to use an update method and a fixed update method. And this method just runs every frame and then runs the logic inside. And the fixed update is a bit different, but works very similarly. So, back on the input manager script, we have this handle movement input script. But in the future, we're going to have things like handle jump input, handle action input. So let's make a public void, public so we can call it on another script. And we're going to say handle all inputs. And then we're just going to put our handle movement input inside here like that. And in the future, I could say, handle jump input. And then I could say handle action input. You can see how just encapsulating this code into one function makes it look a lot neater. It will when we have a lot more added to the script in the future. So that's nice, and since that is public and not private, we're able to use it from the player manager. So we can say input manager dot handle all inputs. Excellent. Now let's do something very similar to our player locomotion. We have our handle rotation and handle movement, but we need to call them somewhere. And we're using fixed update for the reason I will discuss in just a second. So first, let's change this from public to private, and public to private, and then we can make a public function, and we can call this function handle all movement. And then inside this function, we can say handle movement and handle rotation. And then back over to our player manager, we could just say player manager dot handle all movement in the fixed update. And the reason we use fixed update is because when working with a rigid body, it behaves much nicer, and all things that handle moving it should be handled under fixed update. This is a Unity specific rule, not quite sure why, but just know that when moving a rigid body, you should do it in fixed update. So, on our character here, our low poly man for me, I'm just going to go and add a component. I'm going to add the player manager, and then I'm going to add the player locomotion. Now, over in our player locomotion, we actually don't have our camera object declared anywhere, so it doesn't know where to get it, our transform. So we're going to say camera object is equal to camera.main, and then the transform of the camera, so .transform. This will scan the scene for the thing that's tagged main camera. And if we go back into the game, you'll see defaultly in your scene there's a camera called main camera, and the tag is main camera. So, we still need a couple more things. We need a rigid body, as discussed earlier, and we're going to want to go to the constraints. And since we're rotating it ourselves, we're going to freeze our rotation on X, Y, and Z, because we want to handle the rotation manually through our scripts. And then we're going to add a component, a capsule collider. And I'm going to go to my scene view here so I can get a better view of what this looks like. And we want to make it roughly the size of our player. It does not need to be perfect. I'll put mine up to say a height of 1, or Y on the 1, sorry, and a radius of 0.2 and a height of 2. And that looks, we'll say 1.8. That looks pretty great. Alright, now if we hit play, as you can see, we're actually able to move around. But you'll notice our player snaps back to the forward position when we stop. And you'll see in the console here, we're getting a message saying that our look rotation is actually 0. And all we're going to want to do is go right below our target direction at y equals 0. And we're going to say if target direction is equal to vector3.0. And we're going to say target direction is equal to transform.forward. So we'll just basically, we'll keep our rotation at the position that we're looking when we stop moving. And then we hit play again, you will see that we can move around. And look at that, we will just face the way we're facing when we stop our movement. And there we go, we actually got our player to move around. That's pretty cool. Now in the next episode, we're going to make it so he's animated while moving around. So we'll actually have some walking or running animations depending on the speed we are moving at. So if this video is interesting or helpful to you, please drop a like below. It does genuinely help my series get around. If you're feeling super generous, leave a comment to appease the YouTube algorithm gods. And if you're feeling like a total champion, check out my Patreon below. I will see you guys in the next one, where we will handle animating our player, and we're going to explore some really cool themes based on our movement speeds and our inputs.